morning. This week we are going to look at some of the basics of matter, atoms, and elements, those things that make up the periodic table. Matter by definition is anything with mass that takes up space. We typically say that there are 3 stages of matter, although there is a 4th that is discussed as well. But solids, liquids, and gas, each of these 3 things with very distinct characteristics. Plasma is a 4th one that gets mentioned. We won't spend a lot of time with that, but just know that there is, some people say it's a 4th state, some people say it's not really an official state, but it's worth at least mentioning. Solids are rigid. They have a fixed shape and they have a fixed volume. So that's going to differ than a liquid that's not rigid. It does not have a fixed shape, so a liquid's going to take the shape of whatever container it is in, but it does have a fixed volume. So it doesn't matter what shape of container you are. If you have 100 milliliters of water in a spherical container or a square container, it's still going to have, you're still going to have 100 milliliters of water. And gases are not rigid, not fixed, and no fixed volume. So gases can actually be squashed together. Solids and liquids cannot. Like I mentioned before, plasma is a form of matter in which many of the electrons kind of wander around the nuclei of the cell. It is a little bit different. It behaves a little bit differently than solids, liquids, and gases. Atoms are the smallest unit of ordinary matter that form a chemical element. Atoms are made of 3 components. Electrons, which have a negative charge to them, protons, which have a positive charge to them, and neutrons, which have a neutral or no charge to them. So these are called subatomic particles, protons, neutrons, and electrons. If you look here at the model of the atom, you can see that in the inside is a core called the nucleus. And the nucleus contains the protons, the positively charged subatomic particles, and the neutrons, the no charge. Protons are really important because the number of protons in that atom is what's going to give it its distinct characteristics. This is how we're going to ID an atom or an element. They will be atoms of a specific number or with a specific number of protons. Outside of this nucleus, you have all of these electrons then that are floating around in what we would call orbits or shells. And these are negatively charged, so they will be floating around this nucleus. So you can kind of see how an atom is actually arranged. Elements are substances that can't be broken down by chemical means. They're made of very specific types of atoms, and these are all the things that are on a periodic table. So if you're looking at this element symbol here of oxygen, you can see that you will have the element symbol, in this case it's an O. You will have the element name, which is oxygen. You will have the atomic number. This is really important. This is the number of protons that are in the element. And this is the atomic weight. This is the number of protons and neutrons that are in an element. And typically we would round up for this. And at some point we'll explain to you why you end up with a decimal here, but we would round up to 16. So if I wanted to figure out, I know how many protons are in here. Typically in a neutral element, you would have the same number of protons as electrons, right? So positives and negatives cancel out. So 8 protons, 8 electrons. And if we wanted to find out how many neutrons, we would take 16 minus 8, because this is protons and neutrons, and then that would give us the number of neutrons that there were. So there'd be 8 electrons, 8 neutrons, 8 protons. Not every element comes out exactly the same like that, but you get the idea. Isotopes are going to be elements that have different numbers of neutrons. So for instance, here are the elements or the isotopes of hydrogen. Hydrogen has 1 proton. If it has 2 protons, it's not hydrogen, it's helium. So all hydrogens have 1 proton, okay? But some hydrogens have more than 1 neutron. Protium doesn't have any neutrons at all, so the 1 proton sits in the nucleus by itself, okay? Deuterium has 1 neutron. Tritium has 2 neutrons. So isotopes are going to be elements of the same element that have different numbers of neutrons. And the reason we care so much about isotopes is, well, we use them for a lot of different things. You've probably all had imaging done at some point in your life of parts of your body. and those use radioisotopes, and those are going to be isotopes that are really unstable, so they give off radiation, and then we can use that radiation to do different things. These are also, radioisotopes would also be things that would be used in like a nuclear fusion plant. But for most of us, or our purposes, we really focus on how we use the radioactive material to image our body and body parts deep inside. So we know elements can have different numbers of neutrons. The same element can have different number of neutrons. We also know that elements can have different numbers of electrons, because remember, the proton is the identifying piece of an element. So sometimes electrons either pick up or they lose an electron, a negatively charged particle. Okay? So if an element picks up an electron, it's picking up a negative charge, so the element becomes more negative. So for instance, chloride, hydroxide, iodine, these are all called anions because they have a negative charge. And when you see that negative sign there, that indicates that they have more electrons than normal. Sometimes an atom will lose an electron, and thus making it more positive. So in this case, sodium, potassium, calcium, these are common cations. Okay, so cations are positively charged than a neutral atom because they've lost an electron. They got rid of some negativity. You can easily remember these because cation has the plus sign in it with the T, right? So that's a nice, easy way to remember that cations are positively charged versus anions, which are negatively charged. Think of the N. So that's just a real quick video going over matter, ions, elements, radioisotopes. If you have any questions, don't be afraid to ask, and have a fantastic day.